our new unit is trigonometry. We're moving to trigonometry is fun, and if you can label triangles, you'll be able to do trigonometry, and it will be easy. Okay. So let's start with some vocabulary essentials before we start, because we need these vocabulary to be able to, when you read it, you understand what the question is asking. So we're going to start with defining angle of elevation and angle of depression, because these are most commonly seen in word problems. Okay? So I'm standing here, and I am looking at the light, right? So basically, I'm looking this way, right? My view is going up. It's not horizontal, it's at an angle, correct? So I'm looking at the light. The angle between that line right here and the horizontal, which is coming out of my eyes, right? We call that the angle of elevation. So the angle of elevation is measured between the horizontal line and the object. Okay? So this is what we call the angle of elevation. Now, the angle of depression is also coming out of the horizontal, but if I'm looking down, okay? So I'm looking down on the ground, there is a horizontal line coming out of my eyes, and then something that's like a line that's coming out to the object, then the angle between the two is the angle of depression. So the important part is that it's between the horizontal and the object, okay? So this would be my angle of depression. Again, horizontal and the angle of the object.
So that one works for looking down.
This would be for looking down at angle of depression, and angle of elevation is going up, looking up. Okay? So an angle of is an angle that falls from the horizontal, also known as the angle of declination. It falls from the horizontal means angle of depression. Okay? Because it falls from the horizontal. An angle of elevation rises from the horizontal. And also known as the angle of inclination. So whenever they ask you how inclined is the stairs, or how inclined is this this road, right? So you're measuring the inclination, right? So let's say this is the road right here, right? And then you're measuring how inclined is the road, then you measure the angle with the horizontal, right? And that would be your measure of inclination, or in other words, the measure of elevation. Okay? Now, when we're representing angles, so we have a triangle, right? We have angle A, B, C, right? This is a triangle called ABC. A lot of times they like to refer to the angles as a Greek letter. Okay, they use Greek letters. One of the Greek letters that is commonly used is called theta. Looks like an O. Okay, and we usually represent it as a missing angle. Okay, so let's say I'm looking for angle A, I call it theta. It's just a name. Okay, don't get confused with this. It's just a name. You can call it whatever you want. You can call it, I don't know, stuff. Right? So there's theta, beta, alpha. There's many letters that we use, right? But theta is the most commonly used letter. Okay? What do we call the triangle that has a 190-degree angle? That's right. A right triangle. So a right triangle has a 190-degree angle. If it's not a right triangle, then we call it an oblique triangle. So you have two options, either right or oblique. Now oblique will be divided into two. Okay, but we'll talk about that. So any triangle that is not a right triangle is an oblique triangle.
Is it Latino names? Is it Latino names?
I don't know, I don't think so. Now, if you have a triangle, and I'm sure if you have kids in elementary school, you will hear them saying this. Like my kids are in grade 5 right now, and they're talking about acute angles, obtuse angles, oblique, whatever. Like they're talking about all of this, and they're measuring it, and they do like you start learning these from elementary school. So, what is an acute angle?
Middle. Small. Yeah.
A small angle, smaller than what?
90 degrees.
Smaller than 90 degrees, right? So when I refer to an acute angle, I'm referring to angles that are less than 90 degrees, okay? So if a triangle has 3 acute angles, so all the angles are less than 90. So let's say 80 and 20 and 60, right? All these angles are acute angles, correct? So if I have 80, 20, and 60, right? All of these are acute angles, then we call the triangle an acute triangle. Okay? So the word acute,
Anything smaller is cute.
yeah, it's cute. Exactly.
Cutie.
Right? And then also you can refer to these on this right here, on this pink sheet. So you have the right triangle, the right acute, and obtuse. They're right here. I know they're probably hard to see, but you can, like, if you have to get close to them. Now, the minute that one of the angles in the triangle become obtuse, what's an obtuse angle?
Larger than it.
That's right.
Okay, larger than 90.
You know, the word obtuse seems like, you know?
Okay, German.
Larger than 90.
He's talking obtuse.
Obtuse. Right?
Yeah.
It's big. So it's larger than 90. So the minute that you have one angle, because you can't have more than one obtuse, that's larger than 90, so let's say 100 degrees, right? That's one angle that's obtuse, then your triangle is called an obtuse triangle.
One angle only.
Yeah, because you can't have more than one, right? Because if this is 100, you only have 80 left.
Right.
So let's say this is 30 and this is 50, right? There's no way that you can make another obtuse angle, right? Obtuse. So a right angle is 90 degrees. It's just basically what I just said earlier. An acute angle is less than 90, and an obtuse angle is greater than 90.
So, number 9. 9 means
Less.
less.
This means less.
Those are the hungry alligators.
I know. I still don't understand them. When my daughter went, or my son, I don't remember, one of them came to me and were like, alligators will eat this. I'm like, listen, I don't know. Like, I don't know if it's, because I've never learned it that way, right?
Yeah, my
Alligator
daughter was asking, why do we call it with alligator? Why we are comparing with alligator?
Because the open mouth or
Open
whatever.
mouth.
Yeah, I learned it
Open
as
mouth,
Pac-Man.
everyone.
Whatever number's bigger, it wants to eat the bigger number.
Yeah.
That's what I learned.
So, and another thing that you learn, and I was teaching this to my daughter again in she's in grade 5, and she's like, she got me all this sheet of like triangles, and she wants to find the third angle, and I was teaching her all 3 angles add up to
180.
180. In a triangle, always, they add up to 180. Okay? And I'm like, do they need to learn that in grade 5? So I went back and I checked the curriculum. 13 weeks? Yeah. But sometimes sometimes I teach them things not for the grade. And then the teacher doesn't.
Because you're advancing
She's not ready for you.
Okay, so the right triangles, they are special. Okay? They are special because we can treat them differently. We can use different laws for them. Okay? There is what we call the you see the picture right here. So this is a right angle. We always indicate it with a square. We always have the hypotenuse, which is right across from the 90 degrees. The hypotenuse will not change its location. Okay? It's always across from the 90 degrees. Okay? Locate where your 90 degrees is, hypotenuse is across from it. Now the adjacent and the opposite, they will change locations according to your angle of interest. Okay? We're going to talk about this. We're going to talk about the opposite and adjacent, but right now I want you to understand that the hypotenuse is across from the 90 degrees. That's the first side that you want to locate.
If there's not if like it's an acute triangle, how are we gonna find that?
There's no hypotenuse there. Okay? That's why we say, that's why I started my sentence with the right triangles have a special case. Right? Right triangles, we deal with them separately because they're special cases. Okay? So the hypotenuse is always the longest side. I want to tell you why it's always the longest side.
That's supposed to be hypotenuse.
The hypotenuse.
Some of
Yeah.
it's just
Basically, the hypotenuse is the line across the 90 degrees, isn't it?
That's right. It's the
Okay.
side that's across from the 90.
I'm just trying to translate to myself.
Yeah. So let's think about this. I have a right angle triangle. Then this is 90, right? How much do I have left for the other two triangles? The two angles, sorry. I have 90 left for the other two, added up together, right? So the most I can have is 89, right, and 1 if you want, right? That's the most case, right? Or I can have 80 and 10 or whatever. So the other two angles are always smaller than the 90, correct? So mathematically speaking, and if you want to build something, the angle and its opposite side, they always have to match, which means the greatest angle will have the greatest side. The smallest angle will have the smallest opposite side. Okay? So if this is your greatest angle, then this should be your greatest side. Okay? If this is your smallest angle, then this will be your smallest side. So always the greatest angle will have the greatest opposite side. So thinking about this, 90 is the greatest angle and it's always going to be my greatest angle. Right? So that's why the hypotenuse is always your biggest side. Okay? Because 90 will be your biggest angle in a right angle triangle. Okay. Now, when I'm dealing with a right angle, so we know that we have the 90 degree, then we have two other angles that we need to look at. We always have one angle of focus. So this is the angle that I'm interested in. Okay? Could be this one, or it could be this one. Okay? Now it depends on the question. Sometimes the question will say it's this one, sometimes the question is asking for the other. According to which one is my angle of focus, then my opposite and my adjacent are going to change. So if this is my angle of focus right here, so it's either the angle that I'm looking for or the angle that I know. Then this will be the opposite because it's across from it. And this will be the adjacent because that's the one that's adjacent to it, that shares the angle. Okay? Now what happens is, if this becomes my angle of focus, then what's going to happen? Yeah, that's right. The hypotenuse is not going to change. It's going to stay here. But this is gonna become,
Opposite.
and this is gonna be, this is half of your battle, right? Naming your triangle correctly is half of the battle. If you don't know how to name the triangle, then you're gonna use your formulas wrong. Okay? So always you're gonna ask yourself, what is my angle of focus? And then label your triangle according to your angle of focus. Your 90 degree is never your angle of focus. Okay? So the side labeled opposite is across from the angle of focus, and the side labeled adjacent is attached to the angle of focus in the right triangle. Yeah, with a CE and T. And the angle of focus, you might hear me say sometimes the angle of interest. It means the same thing, okay? Focus, interest, same business. Hypotenuse is always across from the 90. Whatever the 90 is. So let's say if my triangle looks like this, right? This is my 90, then this is my hypotenuse. Okay? If my triangle looked like so weirdly like this, right? This is my hypotenuse.
So the
Doesn't
hypotenuse
matter.
all the time across from the 90 degree.
Exactly.
Okay.
Okay? They look like some old things. I'm hungry.
Anytime you say hungry, I'm hungry too.
This is normally lunch.
It is normally lunchtime. Okay. Now, important. Labeling your triangle with respect to the letters. Okay? Angles are labeled with capital letters. Right? So angle A, angle B, angle C, they're capitals, and they are they look like this. So for example, no matter what kind of triangle we're talking about here, okay? We're gonna always label the angles with a capital letter. Yeah, angles, capital.
Okay.
Now, when we're talking about the sides will take the small letters, okay? But not only not whatever, I can call whatever side whatever I want. There is a system for it, okay? So the side across from angle A is called side A. So this would be side A. The side across from angle B is called side B. The side across from angle C is called side C. Okay? There is a system. Okay? Now don't get confused with all these letters because sometimes we use ABC to find Pythagoras theorem. Okay? That doesn't mean there's a complicated system. Okay? So don't get confused with the letters. So this is what I was telling you earlier. So in any triangle, the largest side is always across from the largest angle. And the smallest side is always across from the smallest angle, and so on. Okay? So when you do your math and you finish, check your answer. Okay? This is a way for you to check. Did I get the right answer? Does my answer make sense? Is my biggest angle having the opposite greatest side? Does my smallest angle have the opposite smallest side? Okay? So this is a way for you to check it. Finally is when a question says to solve a triangle, it wants you to find every single side and every single angle. Okay? Solve means the whole triangle. Unless it's specifically asking for a specific side or angle, then you only have to solve for that particular thing. Are we good with that? Good. We're not done. So you should always check that your calculator is in degree mode. Okay? If you, the way to check it is there will be a D on the top or a DEG on the top. Okay? And then some calculator, if they don't have anything, then that also means degree. DEG or D or nothing. But if it says R, that means something's not right. That's not what it means. It means radians, but you know, you need to change it. And if it says, there's a lot. But on the phones, they're a bit different. And I think if it doesn't say anything, that means it's
Because it doesn't have any
Oh.
degree sign over
I always ask where.
just flip it sideways. Yeah, if it doesn't have anything, that means it's
there.
okay.
On